and I'm going to speak about the application of Einstein's equation in lasers. Laser is an acronym for light amplification by stimulated emission of radiation. It describes any device that creates and amplifies a narrow focused beam of light whose photons are coherent. In a laser, the atoms or molecules of the lasing medium, either a crystal like ruby or garnet, or gas or liquid, are pumped so that more of them are at higher energy levels than at the ground state. This was postulated by Einstein in the year 1917. Having turned his attention the year before from general relativity to the interplay of matter and how the two could achieve thermal equilibrium, Einstein devised an further improved statistical theory of heat embracing the quantum of energy. First, Einstein proposed that an excited atom in isolation can return to lower energy state by emitting photons, a process he dubbed spontaneous emission. Spontaneous emission sets the scale for all radiative interactions, such as absorption and stimulated emission. Atoms will only absorb photons of the correct wavelength. The photon disappears and the atom goes to a higher energy state, setting the stage for spontaneous emission. Second, his theory predicted that all light passes through a substance. As light passes through a substance, it could stimulate the emission of more light. Einstein postulated that photons prefer to travel together in the same state. If one has a large collection of atoms containing a great deal of excess energy, they will be ready to emit a photon randomly. However, if a stray photon of the correct wavelength passes by, or in case of a laser is fired upon an already excited state, its presence will stimulate further emission of its presence will stimulate atoms to release their photons early, and those photons will travel in the same direction as that of the stray photon. The photons generated will have identical frequency and phase as the original stray photon. A cascading effect ensues as the crowd of identical photons moves through the rest of the atoms. Even more photons will be emitted from the atoms joining them. So now I'm going to explain about the three processes involved in lasers: absorption, spontaneous emission, stimulated emission. First, let's go on to absorption. In case of absorption, there are two energy levels: E1, the lower energy level; E2, the higher energy level. The rate of absorption defect is proportional to the number of atoms N1 present in the ground state and the density of incident photon, the radiation density, the density of the radiation falling upon them. Rate is equals to B12 N1 rho. This here B12 is the coefficient given by Einstein. B12 is the probability of rate of atoms going from the energy level E1 to the energy level E2. Then let's go to, in case of absorption, the photon hits the atom, it absorbs the energy and goes to the higher excited state. Then from higher excited state, it needs to come down to the ground state again. This can be done in two processes. First, the spontaneous emission, which is the usual process, which is the cause of all the light we see around us, and second, the stimulated emission, the reason for lasers. In case of spontaneous emission, the atom which goes to the higher excited state comes back to the lower excited state by releasing a photon. This is random. This is not stimulated by anyone, and this can occur at any point of time. So here, this is proportional to the number of atoms present in the higher excited state. So, and A21 is also the Einstein's coefficient. It is also the probability of a number of atoms coming down from E2 energy level to the ground state. Then let's come to the stimulated emission, which is the reason for lasers. In case of stimulated emission, the photon comes down to the ground state, but in a different manner. Here, the incident photon, here the incident radiation, if a photon with the energy E2 minus E1 hits the atom in the higher excited state, then it goes down to the ground state by releasing two new photons, which is the cause for stimulation. And the photons which are generated, as I had already said, they have the same frequency as that of the stray photon. Hence, more number of photons are generated. For the application of lasers, the lasers invention launched a multi-billion-dollar industry. Lasers are used to remove unwanted tattoos, to correct vision defects, that is LASIK, to cut through steel and other materials in industrial assembly lines, to scan prices in supermarkets, that is the barcode scanner. It is also used. It is also used in optical discs. Optical disc for storing data. It like caused a revolution in the 21st century. After its discovery, it will cause a revolution in the 21st century by making our lives easier. The lasers are nowadays lasers are also being used in military applications, like there are laser guided bombs, and recently many countries are developing laser guided weapons, which are like in an incoming missile, it won't go on to blast the missile, rather it would burn out. By pointing the lasers at the missile, it is going to burn out a hole and then eventually burn out the electronic devices within the missiles, so that it will be unfunctional. Okay. A video which will be showing about the various application of lasers in modern society. Thank you.
From those epic battles in a galaxy far, far away to alien attacks on the 4th of July, we've all seen those fantastic sci-fi laser weapons. But did you know that real laser weapons are currently under development for various militaries around the world? Get ready to check out 8 insane future military laser weapons. With heavy competition among major weapons contractors to develop laser weapons for the military, innovations in this field are leaping forward. These lasers have moved beyond the laboratory phase to evaluation in simulated combat. In 2013, the US Army tested Boeing's HEL-MD, or High Energy Laser Mobile Demonstrator. This vehicle-mounted system successfully demonstrated its effectiveness on the battlefield by taking down mortar rounds and unmanned aerial vehicles in mid-flight. By mounting the laser on multiple vehicles, this weapon can be used to defend an entire battalion of troops. Even in dense fog, which tends to scatter a laser's light energy, the HEL-MD has performed extremely well. When a mortar or UAV is launched against friendly forces, the HEL-MD uses an enhanced multi-mode radar system to gain a precise aiming point within seconds. After a beam director pinpoints a very specific spot, the laser is fired. Traveling at the speed of light, the laser actually burns into the target, causing catastrophic damage and stopping its progress. Though an explosion isn't typical, if the laser hits an explosive component, it will detonate. Over time, the 10 kilowatt HEL-MD laser can be made even more powerful for destroying larger targets. With the success of the high-energy laser mobile demonstrator, Boeing has also been developing a smaller, lighter version, the Compact Laser System, also known as Silent Strike. Essentially a smaller, less powerful version of the HEL-MD. The system fits into 4 suitcase-sized containers and deploys on a tripod. At 2 kilowatts, the system's compact size enables faster interior motors for tracking and targeting hostile objects. Contained within the cases are a water-cooled chiller, battery power supply, fiber laser, and a totally redesigned beam director. Because the upgraded beam director is so much lighter than its predecessor, Boeing was able to shed about 40% off the weight of the entire system. Yet, like its larger cousin, Silent Strike only requires a single operator. Recently tested in California, the system demonstrated its deadly accuracy by targeting and destroying a tethered unmanned aerial vehicle from a significant but undisclosed distance. By making these weapons more portable, in the near future, soldiers will have new defensive capabilities on the battlefield. Watch as this shipborne laser weapon sets this unmanned drone ablaze. This is the XN-1 LAWS Directed Energy Weapon. During field testing in 2014 aboard the U.S. Navy ship the USS Ponce, the LAWS system not only took out this UAV but also successfully engaged a small unmanned patrol boat. With tracking and firing conducted from a control room aboard the ship, this 30 kilowatt laser can engage enemy targets at light speed from tactically significant distances. Though the US Navy won't define what they mean by tactically significant, most experts believe it refers to the ability to fire the LAWS while still out of the range of enemy fire. One of the LAWS' most insane aspects is that while firing missiles, it can cost hundreds of thousands of dollars each, while one firing of the LAWS laser costs about $1 to $2. Now that's totally insane. After Law's successful test aboard the USS Ponce, the Navy is considering it as a part of the Ponce's approved weaponry. Recently, National Defense Magazine and others have reported that the Law's power will soon be increased to a staggering 150 kilowatts. Enemies beware. Since airplanes first gained the ability to attack ground forces, mounting an effective defense has always been challenging, and at times impossible. Yet with ongoing technological development in directed energy systems, practical effective use of lasers against incoming airborne targets is fast becoming a reality. And not just in the USA. German company Rheinmetall is helping to lead the way with its own high-energy laser. Strangely enough, most traditional air defense systems have gaps that allow LSS, or low, slow, and small targets such as copter drones and model aircraft to penetrate the defended airspace. Rheinmetall's HEL system is capable of eliminating these threats as well as those posed by rapidly moving targets. Using surveillance and fire control radar, the system can focus the beams of several lasers on one specific target, destroying it in the air. In October 2013, Rheinmetall's HEL system was displayed before an international audience, destroying 9 out of 10 mortar fire. Practical effective use of lasers against incoming airborne targets is fast becoming a reality, and not just in the USA. German company Rheinmetall is helping to lead the way with its own high-energy laser. Strangely enough, most traditional air defense systems have gaps that allow LSS, or low, slow, and small targets such as copter drones and model aircraft to penetrate the defended airspace. Rheinmetall's HEL system is capable of eliminating these threats as well as those posed by rapidly moving targets. Using surveillance and fire control radar, the system can focus the beams of several lasers on one specific target, destroying it in the air. In October 2013, Rheinmetall's HEL system was displayed before an international audience, destroying 9 out of 10 mortar-fired steel spheres in flight at a mind-boggling distance of 1,100 meters. The lasers can also be used to dazzle the cameras of suspected LSS targets. If dazzling fails to stop the target, the system can immediately destroy it. In the 2013 demonstration, Rheinmetall's HEL system first dazzled and subsequently destroyed a copter drone. Now being tested on mobile vehicles, the future is bright for Rheinmetall's laser warriors. German company MBDA, makers of a variety of offensive and defensive military weapon systems, has announced the development of a high-intensity laser effector. Intended mostly as an air defense weapon against hostile forces and terrorist threats, the 40 to 120 kilowatt laser will be able to lock on to targets either at close range or at distances of up to 2,000 meters away. The prototype, which has already been successfully tested against UAVs, is hoped to be scaled up for large moving air targets or made compact for smaller threats. Its highly dynamic 360-degree beam guidance system and scalability of power levels could make MBDA's laser effector useful on mobile platforms, permanent installations, and even at sea. Hoping its lasers can become dependable against small targets like UAVs by the end of the decade, the company intends to eventually scale up the laser to a staggering 400 kilowatts. At those levels, MBDA's laser effectors will be able to handle most any incoming ordnance. Moving from destroying mortars and drones, Lockheed Martin is developing systems to take down larger prey with its Atom and Athena high-energy laser systems. Based on their scalable Aladdin laser, these systems precisely control a magnified laser on a 360-degree turret that can fire unlimited shots at enemy targets. The Atom, or Area Defense Anti-Munitions, is designed to engage small rockets, small boats, and unmanned aerial vehicles. Able to track targets at a range of more than 5 kilometers and destroy targets at a range of up to 2 kilometers. This deadly 10-kilowatt laser was recently tested against small military-grade boats. Within 30 seconds, Atom burned through the hulls of these craft with ease. In a test against a small tethered rocket, Atom engaged and destroyed the rocket from a distance of 1.6 kilometers. Atom also took out a free-flying rocket traveling 300 feet per second from 1.5 kilometers, proving its worth in real-life situations. The Athena laser has shown its effectiveness against drone attacks and ground vehicles. With power soon to be deployed in the 60-kilowatt range, Lockheed Martin's lasers will soon be defending U.S. forces in the air, on land, and at sea. For our next item, we're stepping up to some serious firepower. So intense you may not be aware it was even actually attempted. In this video, a short-range missile is being fired upon and destroyed by a high-powered laser mounted on a modified Boeing 747 while in flight. This is the airborne laser YAL-1, reportedly a high-power megawatt-class chemical oxygen iodine laser. Outfitted with precision pointing and atmospheric correction technology, this weapon of the future was actually built and was proven capable of knocking a ballistic missile out of the sky. To accommodate the laser, the 747 underwent modification to its nose section, followed by integration with the laser at Edwards Air Force Base in California. Before engaging the actual missile in flight, the system was exhaustively successfully tested in flight against a simulated missile carried aboard a separate aircraft. The YAL-1 uses a low-power track illuminator laser to locate an aim point for the weapons-grade laser. After compensating for atmospheric distortion, the laser is fired, and the target destroyed. Though the YAL-1's exorbitant cost and relatively short range resulted in the cancellation of the project, further advances in laser technology could eventually revive this insanely futuristic weapon system.